The way that regulations for emissions are set, there is a limit for ground level concentrations, yes. However, a certain amount of times exceeding this limit over a certain time period is allowed. This means that although there is a regulated limit of the concentration of pollutants, it does not mean that the concentration will stay below that point 100% of the time, and in fact is expected to be breached. This next image somewhat demonstrates this, how you can see the plume of emissions rise from the stack here and begin falling toward the ground. This image also brings me to my next environmental and health point for discussion I would like to highlight, and that is in regards to acid disposition, or more commonly known as acid rain. While the effects of inhaling these pollutants directly is now covered, sulfur oxides and nitrous oxides emitted can undergo chemical reactions through mixing in the atmosphere, developing acids such as sulfuric acid and nitric acids, which can fall as precipitation. This increases the acidity of waterways, affects crops, soil, ecosystems, and even dissolves rocks, which can destroy buildings, statues, or other monuments made of stone. All things which would affect the daily lives of Lunarians. Now finally, let us be mindful that the waste produced by the plant is not only expelled in gaseous form. Ash is also produced, and there are two types, fly ash and bottom ash. Indeed, from the EIS shown here, we can see that the plans for ash handling, which are highlighted, includes a lined ash pond for the expired coal. The EIS also refers to the construction of a 1.5 hectare ash pond that will serve this purpose. Here, there is a drawing of the layout of this site. And here's the location of this ash pond for reference. The most common type of coal which is burned is referred to as lignite, and which is likely to be combusted in this plant. It creates bottom ash, which contains highly toxic metals, hence the need for a properly lined ash pond to contain them. When the ash mixes with water from precipitation or water used in cleaning the components of the plant, it forms a sludge. However, dry ash and dry pulverized coal can also be swept up by winds and carried and transported and deposited on lands. The most common means of transport of these ashes is through precipitation that carries the material, or leaches the material as we call it. An ash pond will contain any ashes within it. However, as humans are imperfect creatures, we must also be mindful of the possible outcomes, regardless of how unlikely they are. This is the Kingston fossil plant coal ash slurry spill, which was one of the worst accidents in U.S. history. An ash pond containment was damaged, releasing 1.1 billion gallons of coal ash slurry in the waterways which the plant fronted. This is an aerial image taken the day after the event, showing the spillage as it spread. In the end, after the aftermath of the event, about 1.2 square kilometers of the surrounding land was covered with ash. An environmental disaster indeed. I'm not saying that this is a likely event, but something which has occurred, which we must be mindful of. To summarize, supercritical coal technology is an improvement relative to existing technologies, but not zero emissions or zero hazards. Recall that with the best available cleaning technologies, the emissions would still be present in the quantities which we estimated conservatively. These emissions have very concerning effects, including respiratory and other health problems, including death, but also acid rain. The waste material from this plant, the ashes, can be transported by means of leaching, precipitation, or other methods of washout. For instance, the Philippines is well known for the instances of the rains that come in seasonally. And one thing that we did not manage to mention is the effects of hot effluent water exiting the plant, which will raise water temperatures of the nearby waterways of the nearby coast. This exceedingly high water temperature will cause coral bleaching and can alter the ecosystem of the fish population, which is the livelihood of many local people in Luna. It can in fact reduce the population of fish of this water in the waters near the effluent. Now, the discussion on environment and health can go on. However, it would need a much longer lecture to discuss only this. So, let's move into a shorter discussion about the economic perspective of the proposed plant, including the electricity market and the context of energy in the Philippines and the world. This again shows the rationale as detailed in the EIS for choosing coal for the fuel source of this plant. It is true, as is highlighted, that coal is currently one of the most affordable and widely used, and that it does compose a majority of the electric power generation mix in the world. It is true that coal is an important energy source, and that if we did not utilize it, we would not be able to satisfy our energy needs. What is not mentioned, however, is that many of the largest coal consumers, China included, have vowed to move away from coal for cleaner technologies, and that the cost of energy produced from coal is not always cheaper than energy produced from other sources. When we talk about the cost of electricity sources, a good indicator, a good parameter to look into is called the levelized cost of electricity, known as the LCOE. This parameter takes into account the total cost of building and operating a power plant over the course of its lifetime, divided by the total amount of electricity that a plant will produce over its lifetime. With this, you can get an idea of the cost to produce each watt-hour of electricity that the plant will produce. This does not directly translate into the price that you, the consumer, will pay, as it relies on many other factors in the way that the electricity market is constructed. However, it is indicative of the price that you will pay. Higher LCOEs translate to higher prices. Basically, the more expensive technologies that are in your electricity mix, the higher the end price that you will pay is. There are several columns here, and this is taken from data on the U.S. electricity market, which is well studied and measured. The technologies are the same as what are available for use in the Philippines. The difference may arise in the tax credits that are provided for different technologies due to different governmental regulations between the U.S. and the Philippines. Therefore, we should only look at this column, the total system LCOE. It incorporates the cost of investment and operation, as I mentioned, without tax credits included. The units used here are in US dollars per megawatt hour. Now, among the technologies listed here, there are only 2 coal technologies up here, and these incorporate what is called carbon capture and storage, or CCS. If you recall from an earlier slide, I mentioned that this would be the lowest polluting technology among coal burning ones. But indeed, it is still quite expensive to implement, as can be seen from the high LCOEs. Therefore, to have an idea for comparison purposes of the LCOEs that we would be dealing with, the closest technology to look at is this one called Advanced CT, or Advanced Combustion Turbine. The difference is that this technology uses natural gas as opposed to coal, but for the sake of argument, we will look at this technology. CC, which you can see here, stands for combined cycle, and this is another natural gas technology which is configured completely differently than the system which the proposed coal plant will use. Without getting into too much detail, a combined cycle plant uses 2 turbines for one gas and one for steam, with each power generating unit. But however, returning to the advanced combustion technology economics, you can see here how a majority of this $85 per megawatt hour, or 8.5 cents per kilowatt hour, actually comes from the variable cost for variable operations and maintenance costs. This variable cost comes from the cost of the fuel, and it is the majority of the costs in these types of plants, as is the case with all fossil fuel plants, as you can see from this table. Other technologies which I would like you to pay attention to are geothermal, onshore wind, and solar photovoltaic, or solar PV. These are mentioned as alternatives in the EIS, and if we include hydroelectric power, they are among the most important renewable energy options in the Philippines and in the world. We will discuss more on them later, but I want you to see what the fuel costs of these plants are. Exactly 0, as you can see here. Because the Earth's heat, the wind, and the sun are all free. Investment cost is indeed higher, as we can see here. However, when we look at the overall levelized costs in this column, what we can see is that over the lifetime of the plant, the total amount of energy produced, we can see how our advanced combustion turbine technology is actually more expensive. As I mentioned, this LCOE is slightly indicative of the price. Therefore, it is indeed these costs associated with the type of power, the source where the power comes from, that generates the electricity, that tell more about the final electricity price than to the end user or the customer will pay, than how far the plant is from your house. And indeed, when we look at electricity prices across the ASEAN countries, our neighbors, we can see that the Philippines pays the highest electricity price in all categories: commercial, industrial, and domestic electricity. Specifically, 8.9 pesos per kilowatt hour translates into about 17 US cents per kilowatt hour. This is one of, if not the highest electricity price paid among household electricity users in the world. To give you an example, in the US, the average price is about 14 to 15 cents per kilowatt hour. And in parts of Europe, it can get as low as 11 cents per kilowatt hour. Without going too much into detail, electricity price in a wholesale market structure goes down when you include more power supplied from sources with lower variable costs. Think about which sources had 0 variable costs on the previous slides, or essentially free fuel. Lower prices can be both good and bad from different points of views of the economics, but that is a topic for another discussion.